Today we'll be going over the misconception that when a driver makes a sudden stop that they can fling their arm across and stop the passenger from flying out the windshield.
Whoa! Whoa! Can't stop someone from flying through the windshield with your arm.
So right here we have an FBD for a person in a moving car that's going 15 meters per second. As you can see at the top, there's the force of normal on the person by the seat. To the right is the force applied on the person by the seat. And then at the bottom is the force of gravity on the person by the earth. And force of normal and force of gravity are the same. And then the force applied on the person by the seat is going to the right because the car is pushing back on the person. So the force applied is pushing the opposite direction, keeping the person like in their chair. Additionally, the force applied on the person by the chair, although it is keeping them stable in their chair, is also what is causing the person to move.
As you can see, this is the FBD for a person in a car crash or head-on collision. There is still normal force on person by the seat and force of gravity on person by earth, and these two are still equal. There is also still force applied on the person by the seat going to the right. However, this time there is force applied on person by arm opposing that going to the left. This is the FBD for if the misconception was true. The misconception is that someone can stop the passenger from flying through the windshield with just their arm. As you can see, the force applied on person by arm would have to be equal to the force applied on the person by the seat, and we will explain later why this is absolutely ridiculous. This is the FBD for a person in a car crash. However, this is the FBD that represents what would actually happen in that scenario. As you can see, there is still normal force, force of gravity, and the force applied on person by seat going to the right. However, this time, the force applied on the person by the arm going to the left is much smaller than the force applied on person by the seat. This is because if we use the equation F net equals mass times acceleration, when the car goes from 15 meters per second to 0 meters per second in such a short amount of time, the acceleration is very high. And if you multiply that high acceleration by the mass, the F net is a really high number. This number is almost impossible to achieve with only one arm. Therefore, the force applied on person by the arm is much smaller than the force applied on the person by the seat.
Whoa!